All right, at the top half of this slide, you can see basically the program that we just ran to generate the plot here to the right. So what I want to show you now is that you can manipulate this a little bit. This is a very similar thing. You can see the first few lines here are written so that we are going to basically plot the same thing, the same x-axis, the same y-axis, the same straight line in the color red with symbols O. We're going to set a grid. We're going to use the same title, etc. Same X label and same Y label. Now notice at this point this command hold is inserted. So what I want to look for is what does that really mean? What does it do? And we want to look at the commands that come after hold. So what hold is going to do is hold is going to basically lock in your X and Y axis and so that the commands that follow after are basically going to apply to this previous graph. So in other words, we're going to take this previous plot and we're going to hold on to that plot. And now everything that we do from there on is going to basically plot in kind of like what we plot on top of or modify what we already have. So the first thing you notice is that we have this plot 0.15 minus 0.03 R and 0. So let's come into our previous run and we will rerun this. Okay, and so now what I want to do is we want to come back to this command and I want to enter that, and let's see what that does. So we're going to copy that and we're going to paste it here. And now let's look at our plot and see what happened. So you notice basically what happened here is we plotted a single point. Oh, and I forgot, actually, let me do this over again because I forgot to hold. So let me rerun and then let me hold. And now let me, and you see it's telling me the current plot is held. And now let me come up and let's go back and view it just to be sure it's what we think it is. Yes, it is. And now let me come up to this previous command that we entered. We'll enter that, and now let's see what that did. You notice how it just plotted an extra point here. So we basically plotted a point at x equals 0.15, y equals minus 0.3. We plotted it in red, and we just plotted it with a single point circle. So that's what that one does. So now let's come back and let's look here. And what this one is going to do is this one is going to insert some text onto the plot. So let's do this one now. And we'll come back to MATLAB, just kind of going through one line at a time to see what each one of these does as we do this. Okay, and so now we'll pull up our plot again. And notice we're still kind of on hold here. And notice here it says 0 colon sine of t. So let's come down here and look. So first of all, we tell it to plot at position 0.2 and minus 0.3. So we come to 0.2 and minus 0.3. So what this is doing is these first two things, both on here and on the plot, they're giving you like a coordinate location. Okay, so now at this 0.2 minus 0.3, which is right here on the XY scale, now what it's going to do is it's actually going to plot some text, and the text it's going to plot. And how do you know it's text? Because it's in the apostrophes. So that's telling you it's a string. So you give it this string, and that's what it actually plots here. And then you tell it, yes, I do want to choose the color. I want the color to be red, and I want the font size to be 16. So basically, you've added this to your existing graph. So now let's come and look at this line. This says axis. Now remember that you're holding on to this prior plot, but now what we're going to do is we're going to set the axis. So when we set the axis, what have we done? We basically have changed the limits of the x and y axis, and this is extremely useful because what this means is if you have multiple sets of data and your data sets have different limits, like let's say one of your data sets runs from -2 to 2 and the other one runs from -1 to 1, then what you can do is you can go in and you can physically set the limits on your axis so that everybody's sort of plotting on the same graph. You can see everybody at one time. Your x and y axis are optimized for a given set of values. Okay, and then finally, let's come here and we will once again do a copy, and we'll once again do a paste here. And let's see what this last line does. So window, figure 1. Okay, and primarily it looks like mostly what happened was we changed the background color to yellow. We also manipulated a little bit the line width on the plot. I don't know if you noticed or not, but the plot axes got thicker. And so we set those at thicker. That's this line width. 2.5, so that's telling us to set the line width. It's telling us to set a color to be Y, and then basically you notice everything on the axes, sorry, let me go back. Everything on the axes changed font size. It's all now font size of 16. So by adding, so this GCA, we can come here and look at what GCA does. So GCA basically gets the handle to the current axis. In other words, the current axis is the axis that all these graphic commands will draw to if issued. So when we came in and we said that that we wanted to set the line width and the color, it's going to default to the plot that's currently being held. If there were, so that's what that's doing, is that's just telling you for the plot that's currently being held, we want to set the line width, we want to set the color, we want to set the font size. So that pretty much covers how you can manipulate axes and color and things like that. And you can see the difference here. The main difference being that when this reset, due to our command here, you notice it reset the size of the axis markers. So in other words, the font here is bigger than it is here. So that's part of what this font size reset did. So once again, we haven't covered anywhere near all the possibilities on MATLAB plots. There's just a ton of stuff that you can do. All right, well now let's look at another possibility, and that is the subplot. So the subplot's really interesting. What the subplot does is it allows you to plot multiple plots in on one page or on one overall plot. So notice here that we're plotting y is equal to the sine of t, y is equal to the cosine of t, and we've got some changes in color here. The first one is red, the second one is going to be blue, the x and y axis labels are the same. This one has red circles and a solid line. This one has blue circles and a solid line. Let's go to the next page. We have two more subplots. This one is a combination of sine and cosine, and this one is 1 over sine. And so what happens is, notice everybody's plotting on the same x-axis, t over pi, and then the first subplot plotted y1, the second subplot plotted y2, the third subplot plotted y3, and the fourth subplot plotted y4. So the 2, 2, 3, let's look at that. So first let's clear all, and then let's do help subplot. And come all the way up to the syntax. So basically, it breaks the figure window up into an m by n matrix of smaller figures. So the 2, 2 would mean we're going to have 2 rows and 2 commas of graphs. 2 rows and 2 columns of graphs. So if you go back to our figure, which will be generated right here, notice we have 1, 2 rows and 1, 2 columns. Had we said 1, 4 or 4, 1, we'd end up with either a long row or a long column of graphs, just depending on how we set that up. So it'll divide this into 4. This is going to save as one figure with multiple subplots on the figure. So this is also pretty useful, especially if you're comparing data sets from different experiments or comparing different mathematical curves. This turns out to be a pretty useful thing to do as well. Here's some more examples of two-dimensional plots in MATLAB. You can look at this one. We basically are plotting the cosine of t squared. We have an x-axis, we have a y-axis. The main difference between the top graph and the second graph, if you notice, the x-axis label or the x-axis tick marks are more frequent. So up here we have 1, 2, 3, 4. Down here they're marked off in 0.51, 1.52. So if you look right here at these two commands, so first of all, this top graph is generated the same way as the bottom graph up until this point. The set here is basically saying for this plot we want to set the font size, we want to set the line width. So that gives us the font size on all the labels and on the axis markers, and it also gives us the line width. So we can manipulate that however we want. It tells us we've got the title here, it's exactly the same. But when we get down here, we basically set up an array, and we'll call the array A, and it goes from 0 to 4 in increments of 0.5. So then down here we have set, and so we're basically saying, okay, for our current graph, we're going to set the font size to be 18. We're going to set the line width to be 2.5. Now we've already done that up here, so we're basically just repeating that. But now what we're going to add is where we want to set the tick marks on the x-axis. So x-tick is basically set to be A. A is the matrix that we previously defined. So what this tells us is we want to put tick marks on the x-axis starting at 0, ending at 4 in increments of 0.5. So that's also a pretty useful little command because it allows us, if we want to see in more detail, for example, you can see that this is a sine wave and the frequency is changing pretty rapidly from 0 to 4. And so if we want to see more detail, especially when we get to these rapid changes down here, then that illustrates that a little better. Okay, so that concludes some of the discussion on 2D plots. All kinds of other plots that you can do in MATLAB. You can do contour plots. You can do numerous other, I think you can actually pull up how to do a contour plot. Basically, it'll draw a contour plot in the XY plane. So this is like if you were doing mapping, or if you were trying to indicate, for example, let's suppose you had like a thermal camera and you were trying to illustrate on an XY plane what temperature was. So you could actually draw temperature contours if you had the data of temperature at each plot. So it's kind of a variation, or at each point. So it's kind of a variation of how to do a three-dimensional display of data on a two-dimensional plane. You can see this in things like geospatial information systems. We'll see it in thermal management kinds of problems. You can sometimes see it in image processing. When you look at things like plots of activation of brain regions, when you're looking at functional MRI data, you'll sometimes do contour plots, or sometimes also you'll do color intensities. So MATLAB, one of its best strengths is its ability to do really outstanding